Hi and Assalamualaikum. Before we start our presentation, let us introduce ourselves. We are from AM001D, Group 5, and my name is Hani Safia binti Mustafa. My metric number is 2025293752.
Assalamualaikum. My name is Nurul Nabila binti Abdullah and my metric number is 2025865474.
Assalamualaikum and hi, my name is Amani Shafa binti Hamzah. My matrix number is 2025890098.
Assalamualaikum and hi everyone. My name is Fasha Kaisara binti Hairul and my matrix number is 2025207748.
Our first case study is compound interest, and I will start with the introduction to compound interest. The citation of the introduction is by Jason Fernando, 2016. Compound interest is interest that is added to the initial principal of an investment or loan, thereby increasing the balance and in turn increasing the amount of interest earned or paid in the next period. This concept is commonly applied in savings and investment accounts where the returns grow over time as interest continues to compound.
Problem statement for case study 1. Jackson, a small business owner, plans to save his money in a Maybank fixed deposit account. He intends to deposit 5,000 ringgit for a period of 5 years. The bank offers an annual interest of 1.80% compounded quarterly. Objectives for case study 1. Number 1. To determine the accumulated amount at the end of the Jackson's saving period. Number 2. To calculate the total interest received by Jackson. Number 3. To calculate the account balance at the end of the saving period when Jackson deposits an additional 3,000 ringgit into the same account 3 years after his initial deposit. Number 4. To calculate the accumulated amount at the end of the saving period when the interest rate changed to 2.10% compounded every 2 months 2 years after his initial deposit.
Before we move on to the calculation, we have to create a timeline. Our timeline will start at P, which is the principal amount, and ends with S, which is the accumulated amount. From the question, we can subtract that our K, which is our annual interest rate, is 1.80%, which is equivalent to 0.018, and our M, which is the frequency of the conversion, is 4 because it is compounded quarterly, which means every 3 months. And then our T, which is the time length in years, is 5 years. To find our I, which is our periodic interest rate, we need to use the formula of I equals to K over M, which is I equals to 0.018 over 4 equals to 9 over 2000. Afterwards, to find our N, which is the number of interest period, we need to use the formula of N equals to M multiplied by T, which is N equals to 4 multiplied by 5, and then we get 20.
To begin our objective 1, the calculation is carried out to determine the accumulated amount at the end of Jackson's saving period. To solve this question, we need to use the formula S equals to P multiplied with 1 plus I to the power of N. Next, we need to substitute the information using the formula. So, S equals to 5,000 multiplied with 1 plus 9 over 2,000 to the power of 20. By applying this formula, the result obtained is Rm 5,000 ringgit 469 ringgit 77 cents.
Moving on to objective 2, we need to calculate the total interest received by Jackson using the formula of I equals to S minus P. Therefore, we can subtract our S from the answer of the first objective, so it will be I equals to 5,469.77 cents minus 5,000, and we will get our final answer, which is I is Rm 469.77 cents.
Objective 3. To calculate the account balance at the end of the saving period when Jackson deposits an additional 3,000 ringgit into the same account 3 years after his initial deposit. So, the timeline is P1 equals to 5,000 ringgit and P2 equals to plus 3,000 ringgit. Time length or T1 equals to 3 years and T2 equals to 2 years and T equals to 5 years. Annual nominal rate or K equals to 1.80% equivalent to 0.018. Frequency of conversion or M equals to 4. Periodic interest rate or I equals to K over M equals to 0.018 over 4 equals to 9 over 2000. Next, we want to get the number of interest period, so we need to use the formula N1 equals to M multiplied with T1 equals to 4 multiplied with 3 equals to 12. Next, N2 equals to M multiplied with T2 equals to 4 multiplied with 2 equals to 8.
Objective 3. So the formula is S1 equals to P1 in bracket 1 plus I to the power of N1. S1 equals to 5,000 multiplied with 1 plus 9 over 2,000 to the power of 12. So the answer is S1 equals to 5,276 ringgit and 78 cents. The next formula is P new equals to S1 plus or minus P2. P new equals to 5,276 and 78 plus 3,000. P new equals to 8,276 ringgit and 78 cents. The last formula is S equals to P new in bracket 1 plus I to the power of N2. S equals to 8,276 and 78 multiplied with 1 plus 9 over 2,000 to the power of 8. So the answer we got is 8,579 ringgit and 48 cents.
Objective 4. To calculate the accumulated amount at the end of the saving period when the interest rate changed to 2.10% compounded every 2 months, 2 years after his initial deposit. Since the interest rate changed, we need to use the new timeline for this calculation. The principal amount, P, equal to 5,000 ringgit. We want to find the accumulated amount, which is S. The times T1 equal to 2 years, while the T2 equal to 3 years. For the annual nominal rate, K1 equal to 1.80%, equivalent to 0.018, and K2 equal to 2.10%, equivalent to 0.0210. For the frequency of conversion, M1 equal to 4 and M2 equal to 6. Periodic interest rate, I1 equal to K1 over M1, which is 0.018 over 4, equal to 9 over 2000, while the I2 equal to K2 over M2, which is 0.0210 over 6, equal to 7 over 2000. Lastly, the number of interest period, N1 equal to M1 multiplied with T1, which is 4 multiplied with 2 equal to 8, and the N2 equal to M2 multiplied with T2, which is 6 multiplied with 3 equal to 18. To find the answer, the first formula we need to use is S1 equal to P in bracket 1 plus I1 to the power of N1. S1 equal to 5,000 multiplied with in bracket 1 plus 9 over 2,000 to the power of 8. S1 equal to 5,182 ringgit and 86 cents. The second formula we need to use is S equal to S1 in bracket 1 plus I2 to the power of N2. S equal to 5,182.86 multiplied in bracket 1 plus 7 over 2,000 to the power of 18. S equal to 5,519 ringgit and 28 cents.
The second case study is annuity. An annuity provides a series of fixed payments over time, and the total amount someone receives is influenced by how long they are expected to live and how well the underlying investment performs. Annuity is used for insurance payments, loan repayments, and investment income. This is said by James M. Potterba on 2001. Problem statement for case study 2. Ali wants to buy a car. He is interested in buying a 2019 Honda Civic in black that gives the car a sporty and sophisticated look. The cost of the car is 79,900 ringgit. He decided to pay 10% as a down payment, and the remaining balance will be financed through a loan under CIMB car loan. The bank offers an interest rate of 4% compounded monthly. The loan will be settled by making monthly payment for 9 years.
Your objective for case study 2, annuity. The first one is to determine the amount of monthly payments paid by Ali. The second one is to calculate the total interest incurred by Ali. The third one is to calculate the total outstanding balance if Ali decides to settle the loan immediately after making the 100th payment. Last but not least is to determine the amount of outstanding areas that must be settled in the next payment if Ali has missed 4 consecutive monthly payments.
Before we start the calculations for case study 2, we go through the information. The cost price, CP, is RM79,900. Then, we need to find the down payment, DP, which is 10% multiplied with RM79,900 equal to RM7,990. After that, we calculate the balance, B, using the formula CP minus DP, which is 79,900 minus 7,990 is equal to 71,910. The balance, 71,910 ringgit, will be our present value of annuity, which is A. Next, the annual nominal rate, K, is equal to 4%, equivalent to 0.04. The frequency of conversion is 12, since the loan is compounded monthly. The timeline in year T is 9 years. To find N, we need to multiply M with T, which is 12 multiplied with 9 equal to 108. Lastly, our I equal to K over M, which is 0.04 divided by 12 equal to 1 over 300.
To address objective 1, the calculation is carried out to determine the amount of monthly payments paid by Ali. For this question, we need to use the formula A equals to R multiplied with 1 minus in the bracket 1 plus I to the power of negative N and then divide with I. But we need to rearrange the formula to solve the R, which is R equals to A multiplied with I divided with 1 minus in the bracket 1 plus I to the power of negative N. After that, we need to substitute the information using the formula. So, R equals to 71,910 multiplied with 1 over 300, then divide with 1 minus in the bracket 1 plus 1 over 300 to the power of negative 108. By applying this formula, the answer is going to be Rm 793 ringgit 96 cents.
For the second objective, we are calculating the total interest incurred by Ali. The formula we use is I equals to R times N minus with A, which is equivalent to I equals to 793.96 cents times with 108 minus with 71,910. So we get the total interest, which is Rm 13,837.68 cents.
Objective 3. To calculate the total outstanding balance if Ali decides to settle the loan immediately after making the 103rd payment. So we use the formula N unpaid equals to N total minus N paid equals to 108 minus 103 equals to 5. Afterwards, we use the formula AN equals to R open bracket 1 minus open bracket 1 plus I close bracket to the power of negative N close bracket over I. Then we put the information that we have. A5 equals to open bracket 793 and 96 close bracket open bracket 1 minus open bracket 1 plus 1 over 300 close bracket to the power of negative 5 close bracket over 1 over 300. So we get the answer A5 equals to 3,930 and 41 cents.
Objective 4. To determine the amount of outstanding arrears that must be settled in the next payment if Ali has missed 4 consecutive monthly payments. So, first we need to find the value of N unpaid, which is missed payment plus 1. So, 4 plus 1 equal to 5. Now, we are going to use the formula of Sn equal to R in bracket 1 plus I to the power of N minus 1 divided by I. S5 equal to 793.96 in bracket 1 plus 1 over 300 to the power of 5 minus 1 divided by 300. So, the answer is S5 equal to 3,996 ringgit and 35 cents.
In conclusion, from the topic compound interest helps us see how money can slowly but powerfully grow over time when interest keeps adding onto itself. We learned that starting to save early really makes a big difference even with small amounts. In real life, this applies to things like savings account, investments, and retirement funds, where our money can grow steadily for the future. Meanwhile, from NWT, the topic teaches us how regular payments made over time can help us reach our goals or manage our commitments. We learn how to plan using the present and future values of payments. In everyday life, NWTs are used for things like loan repayments, education savings, and retirement contributions, helping us to stay organized and disciplined with our money.